How to use a Born Haber cycle to calculate lattice enthalpy. So this is taken from the OCR 2007 S325 specimen paper. And we're given a table of enthalpy changes. And the question says, complete the Born Haber cycle for calcium oxide below. Use the data in table 4.1, this one here, to calculate the lattice enthalpy of calcium oxide. So in a Born Haber cycle, what we're going to do is we're going to change all of the elements into atoms. Then we're going to ionize the metal. We're going to add electrons onto the non-metal, and then we're going to stick them together to make a lattice. So the first thing we're going to do is we're going to take the calcium gas and we're going to ionize it. And this is the first ionization energy of calcium. The next step is we need to remove the second electron from calcium. And this is the second ionization energy of calcium. And it's worth pointing out that if this number here is positive, i.e. it's an endothermic process, that the arrows go up. And if it's an exothermic process, the arrows go down. Now we've made our calcium 2+, we then have to add an electron to oxygen. And this is the first electron affinity of oxygen. And this is minus 141. And because it's exothermic, the arrow goes downwards. And it goes from O to O minus. And one of the electrons that we got off the calcium goes on to the O minus, which leaves us with one electron left. The next step is the second electron affinity of oxygen. And this is plus 791. Because this value is positive, it's endothermic, the arrow goes up. And this electron sticks onto this oxygen, so it becomes O2 minus. The reason why this is endothermic is because you're trying to push a negative electron onto an already negatively charged O minus ion. And because it's a negatively charged electron and a negatively charged O minus ion, the two things repel, so you have to put energy in the system to make the two things go together. The last arrow is the lattice enthalpy, and this is what happens when you add Ca2 plus gaseous plus O2 minus gaseous, and we end up with calcium oxide solid. So this whole thing here is a Born Haber cycle. If we add the numbers on, which we get from the table, we end up with these. The easiest way to think about it is a bit like a giant Hess's law diagram. So we can either go from there to there, which has got a value of minus 635 kilojoules per mole. Or we can go there, there, up there and down there. And all of these numbers, that, plus that, plus that, plus that, plus that, plus that, plus this, which we don't know, equals 635. So this arrow here is equal to the sum of all of these arrows there. And we can put that in an equation that looks like that. Now the question asks us to use the data to calculate the lattice enthalpy of calcium oxide. So if we rearrange this equation, or put it in the calculator, we find out the lattice enthalpy, this arrow here, is equal to minus 3451 kilojoules per mole.